All right, so what values of x and y would make this equation true? Ben?
0.
Okay, so at least one of the values must be 0, right? So x can be 0 and y can be whatever it wants to be, right? Or y could be 0, x could be whatever it wants to be, or they could both be 0, which would still make the equation true. Okay, so that's where at least comes from. All right. Does anybody remember, so we have x squared plus 2x, and we have x squared plus 5x minus 24. What form is this in? So it has the biggest exponent first and then in descending order. Standard. Good, standard form. Okay, standard form. All right, so if that is standard form, do you guys have any guesses as to what this form would be? Think about what I did to get from standard form to this form. What did I do? Yep.
Expanded form?
It's not expanded form, but that's not a terrible answer. Not a terrible guess. Good guess. What have we been doing? What's this unit all about? Factoring. So this would be called what form? Factored form. Awesome.
Is that Boston?
Yeah. I grew up in New Hampshire.
Really?
Yeah. Okay. Oh, great. That's on the notes. Okay, so I want you to, whatever way you like to make notes to yourself, so I'm going to highlight it and star it so you guys know that this is super important. Okay? So next to factored form, I want you to write must be in factored form to solve. Okay, so in order for me to solve, which is what we're doing today, I must have my equation in factored form. Okay? So if my equation's in standard form, what must I do to it? Factor it, right? To get it in factored form. Okay, simple. Okay, great. All right, let's scroll down here a little bit. So the blank is equal to the number of blanks. Does anybody remember, I told you that you did not have to remember this, so if you don't, I'm not going to be mad. Does anybody remember what this 2 is? Wow, that's really crooked. There is a name for that 2, the highest exponent. Do you guys remember what that's called? It starts with a D. It's okay, I told you didn't have to know it. Degree, does that ring a bell? Degree, okay. So down here I want you to put highest exponent slash degree is equal to the number of solutions. So we're solving today. So the number of solutions will be based on the degree. However, since I didn't have you memorize the degree, we need to come up with a different way to kind of think about how to know how many solutions there are, right? So, since we're solving in factored form, that is going to come from this form. So I want you to think about this form in parts. So what I mean by that is this term out here, this GCF that we took out, that is one part. And this set of parentheses right here is another part. So does everyone see where the parts kind of break up? So I'd have 2 parts right there, which means I'd have how many solutions? 2. Good. All right, so in the second one, how many parts do I have? 2. Good. Which are they? What's one?
The x minus 3 in the parentheses and then the x plus 8 in parentheses.
Good. So I have x minus 3 in parentheses as my first part. And I have x plus 8, which is my second part. So I'd have 2. Okay. So notice that matches our degree and our highest exponent. So down here, go ahead and write number of parts as well. Okay. All right, let's go ahead and try one. All right, so what form do I need in order to solve? Factored, good. Is number 1 in factored form?
Yes.
Awesome. All right, so if it's already in factored form, now I need to come up with how many parts I have, right? So how many parts do I have here? 2, good. So x would be my first part, right? And my second part would be what? Good, x plus 5. Okay, good. So we identified our parts. All right, make yourself a little note off to the side over here. To solve, set all parts equal to 0. Okay, so in order to solve these, we have to set every part that we come up with equal to 0. All right, so our orange part is x, right, and there's nothing else to it. So we get x equals 0, and that would actually be our first solution, x equals 0. Okay, so that one they kind of solved for us pretty easy, x equals 0. All right, what's our second part we already came up with? Oops. We have x plus 5, right? That's our second part. So now I must set x plus 5 equal to that 0. How do I get 5 by itself? I heard somebody over here say it. Aaron, did you say it? What'd you say?
Subtract.
Good, I need to subtract 5 from both sides. So I'd get x equals negative 5. All right, so my two solutions here would be x equals 0 and x equals negative 5. Okay, let's start number 2 together, and then I'm going to have you guys finish it on your own. All right? No, we're going to add some more to it. Yep, all you're doing is solving the solution, or getting your solution, solving the factored form. Okay, so for number 2, how many parts do we have? 2, good. We have this one, and we have this one. And how do I solve for my values? How do I get my values? How do I solve? I have to set my parts equal to 0, good. All right, go ahead and try that at your table. Set both parts equal to 0 and tell me what you get. All right, so let's talk through this. So I set my first part, 2b minus 6 equal to 0, right? In order to solve, I have to do PEMDAS backwards, right? So I need to think about addition and subtraction first. So I'm going to add my 6 to both sides. And if I do that, that gives me this 2b equals 6, right? Then I need to divide by my 2 on both sides. And when I take 6 divided by 2, that gets b by itself, and I get b equals 3. Does that make sense? Okay. All right, so now my next part was 3b plus 18 equals 0. So once again, I subtract my 18. I would get 3b equals negative 18. Divide both sides by 3. My 3's cancel, and I'm left with b equals negative 6. Okay. How are we feeling? 3, 2, 1. Okay. All right, go ahead and try number 3 on your own. All right, how'd you solve this one? Somebody tell me what you did. What'd you do?
Oh, I did that wrong.
What did you do? Yeah, Ben?
I distributed the exponent 2 to both of the figures inside the parentheses.
Okay, so you like rewrote it out, x minus 3 and x minus 3?
Yes.
Okay. Set equal to 0. Okay, good. All right, popcorn to somebody else. What do I need to do now? Lennon?
And then you should get 2x minus 6.
So remember, I'm not going to multiply, I'm trying to solve, right?
That's embarrassing. Never mind.
That's okay. All right, what do I do next? What do I need to identify? identify my parts, right? Parts. Okay. So what is one part? Good, x minus 3. And my other part would be x minus 3. So when I solve, I would get x equals 0, right? And I would just get x equals 0 twice. So you can just write it once. Okay, x equals 0. I'm sorry, x equals 3.
Oh, I say, whoa.
My bad. My bad, my bad.
I was like, I thought I got this.
It's magic math.
Maybe not.
Don't you guys know that 0 minus 3 equals 0? Of course. It's new math. All right. All right, so let's move down to page 2. All right, so what is different about this one?
It's a standard.
Yes, good. So this equation is in standard form. So what do I need to do to it? Good, I need to factor it to get it in factored form. All right, first thing, can I take out a GCF? No, why not? Good, so I have a 1 as my coefficient, so if I were to try to divide anything, I'd get a fraction, and that would be oh so sad. Okay? No bueno, that's right. All right, so my C value is what I need to look at next. So I need to find the factors of my C value, which in this case is negative 18. Okay, so what are some factors of negative 18? Good, negative 9 and 2, which means I can also have positive 2, or negative 2 and positive 9. Good, negative 6 and 3. What else? Negative 18 and 1 maybe. All right, do I see any thus far that add, that add to negative 7?
Negative 9 and 2.
Good, negative 9 and 2. Okay. So if I were to rewrite this, whoopsie, I would get x minus 9, x plus 2. Do y'all agree? Okay, but what something that I cannot forget to do is I need to bring down this equals 0. Okay, that reminds me that I need to set each part equal to 0. All right, so just like above, I identify my parts. So my first one is x minus 9 equals 0. So x would equal
9.
Good, 9. Okay, so there's my first solution. Second solution, x plus 2 equals 0. Subtract 2 from both sides, and I would get x equals negative 2. Okay, those are my two solutions. All right, together.
What is that? The only thing?
Yep, so it says solve the equation. So you are trying to find the values of x that would make that equation true.
So we don't have to do anything for negative 7x and x squared?
So what we did was we factored that standard form to get it into our, factored standard form to get it into factored form. So this right here is the same thing as this right there. These are equal to each other. So then I can go ahead and solve. Okay? So if I write standard form and factored form, it's the same thing if I multiply it out. Those are equal to each other. Okay, good question. All right, so go ahead and work together on numbers 2, 4, 6, and 8. I will warn you, 4 requires some brain power, but you can do it. Okay? 2, 4, 6, and 8. Let's go over number 4. All right? So first things first, what do I always need to look for? Good, a greatest common factor. What can I take out of all of these terms? Good, I have a 2. Anything else? Good, n squared. So if I divide a 2n squared out of all of these terms, that becomes a 1. What would I be left with? N, good. My n squareds over here cancel out. Negative 20 divided by 2 would be minus 10. Drop down my equals 0. Okay? How many parts do I have?
2.
Good, 2 parts. So let's start with the first one. 2n squared equals 0. All right, this tripped a lot of people up. Okay, well, yep. Oh, you can go for that. All right, what do I do first, Caleb?
Divide both sides by 2.
Good, so I'm going to divide both sides by 2. All right, and that gives me n squared equal to 0. Does anybody know what operation I can do to get rid of an n squared term? To make it a regular n term. What is it? Good, I can take the square root of both sides, and that would get me n equals 0. Okay, so there's my first solution. All right, so now I need to set my second part equal to 0. So I have n minus 10 equals 0. Add 10 to both sides, and n equals what? Good, n equals 10. Okay, how are we feeling on that one? Good? All right, let's try 6. 2 and 6, or 4 and 6 were the hardest, I think. All right, let's go over to 6. All right, so once again, I need to look for a what? Greatest common factor. Good. What do I have in common with each term here? Good. I heard somebody say 4. How many x's can I take out of each? 2. Good. All right, so if I divide everything by 4x squared, that leaves me with what? My 4's cancel out here, and I have 4 x's on the top and 2 on the bottom. So if I were to cancel those out, how many would I be left with? 2, good. x2. All right, minus 4x cubed over 4x squared. What would I be left with there? Good, and minus x. And finally, my x squareds here cancel out on the top and bottom, so I'm left with negative 24 over 4, which gives me what? Good, a negative 6. All right, am I done?
No.
Good. All right, so I need to try and factor what? I need to try and factor this piece right here more, right? Because that looks like something I've seen before. Okay? So, can I take out a GCF? No. Good. I need to get my C, right? So negative 6. What are some factors of negative 6? Good. 2 and 3, but one of them's got to be negative, right? 6 and 1. Once again, one of them has to be negative. Okay. Do any of these so far add to a negative 1? Which one?
2.
Good. 2 and negative 3. All right, so if I were to rewrite this, whoopsie. I would get 4x squared, x plus 2, x minus 3. I drop down my equals 0. Is everybody with me on that one? All right, so now I'm going to separate my parts. My first one is 4x squared. I'm going to set that equal to 0. Once again, I'm going to divide by 4 like Caleb told us to do. And I get x squared equals 0. Okay, now I need to take the square root of both sides. And I am left with x equals 0 again, right?
Can you move that up just a little bit, Miss Cooper?
Yeah.
Thank you.
Yep. I'm going to erase our factors over here so I have some more room. Okay, so my next part is x plus 2. So x plus 2 equals 0. So my x would be equal to what? Good, negative 2. Subtract 2 from both sides and get x equals negative 2. All right, and finally, my last part is this x minus 3 term right here. So I have x minus 3 equal to 0. If I add 3 on both sides, I get x equals 3. So my solutions for that one are x equals 0, x equals negative 2, and x equals 3. Okay? All right. Go ahead and start your prep for the last few minutes of class here.